Welcome to Manning Publications Twitch channel. I am your guest host, Richard Nuckolls. I am an author for Manning of the soon-to-be released Azure Storage, Streaming, and Batch Analytics book. Should be coming out in the next month. In the book, I cover several services, including storage counts, data lake stores, and data lake analytics, and teach you how to build a Lambda designed, architected data analytics processing system in Azure using services that you can wire up together with no code, and offers you the power of running high throughput, highly parallel jobs, both in batch and streaming data processing, so that you can run large data loads through your analytics pipelines and get results in a short period of time. Today's streaming session, we're going to be talking about Data Lake Analytics, which is a batch processing analytics service in Azure designed to integrate with the Data Lake Store and Azure Storage accounts for reading large, very large, and extremely large data sets and easily scaling through parallel cluster nodes to run these giant analysis queries in long and short periods of time. Because it's a SaaS service, you don't have to worry about defining the background node cluster or managing nodes or starting and stopping the service. You pay on demand for the usage that you put to it. So in that way, all you have to worry about is learning how to write the queries and use the service to its best effect for running your batch jobs. One of the main points of the Data Lake Analytics service is the use of the U-Sql language, which is not quite ANSI SQL, not quite T-SQL, and certainly not C#, but it's a mix of all of those, designed so that developers and data analysts who are familiar with SQL queries can jump in and create queries quickly once they've learned the language and the style of read, analyze, output that the Data Lake Analytics node processing requires. In this way, you don't have to learn how to manage the cluster. You just jump in, write your queries, and send them off running. U-Sql is sort of a blend of SQL declarative language and C# iterative definitions and C# variable types. And one of the things that blending these two things together gives you is the ease of writing select statements, aggregations, and the other type of commands that you're familiar with SQL, and being able to add in special processing, special calculations, special data handling with C# language additions. We're going to go over some of this in today's streaming session. And now that we've got all of that out of the way, we're going to get started by setting up a new service. I'm going to say you're likely familiar with using Azure. You've got your subscription set up if you want to follow along. There are multiple ways, of course, to create a new service. This is one of the easiest ways, is going to the All Services and searching for your service. Your Data Lake Analytics requires 3 things to set up and run. Of course, you need a resource group. You need a name for the Data Lake Analytics account. The name actually needs to be a fully qualified, not a fully qualified domain name, but a routable and globally unique name. So you don't get to use dashes, period spaces, or other types of indicators in this like you might with some other services in Azure. In this way, it's actually quite similar in naming to both your Data Lake and your Azure Storage accounts. You need to pick the location. Data Lake Analytics is rather restrictive in the places where you can run it. We have 2 options in Europe and 2 options in the US. It's one of the things you want to think about when you start provisioning resources in Azure. If you haven't already, pick a region in Azure and put your services there, and try to think out what type of services you want to use and what type of global distribution you'll want to use. Some services automatically are available worldwide. Some have specific matching pairs of regions where they'll be duplicated and you already have the built-in integration. And some services are either new or slowly rolling out to other regions, and you're restricted as to where you want to run them. You do want to keep services within the same region to minimize your latency and your data egress charges. The last thing we need is a Data Lake Storage Gen 1 account. The data lake that's assigned to this Data Lake Analytics holds a number of things related to the Data Lake Analytics service, including stats and compiled code and other data around the actual jobs that you've run, and a special feature called the U-Sql catalog, which can contain precompiled data, assemblies, and precompiled scripts so that for reuse later in your U-Sql jobs. So you have to have a Data Lake Storage Gen 1 account. You can create one, of course, here, as you can with most services in the portal. You can create dependent services right in the same blade. In this case, I've already set up EastUS2 demo dev for a storage account and preloaded some data there. So we'll have this going a little faster. One thing you want to consider when you've used Data Lake Analytics for a while, or you're considering spinning up a second or a third account for doing different types of processing, or having different divisions do different processing in parallel with each other. You can select monthly commitments once you have an idea what your usage is going to be. Rarely will you know what your monthly commitment will be when you first create your Data Lake Analytics account. So I'd always recommend that you choose pay-as-you-go in the beginning. But if you do pre-purchase AU hours, you can get a significant reduction in cost. And you can change to a pre-purchased pattern once you've set up your account in the second, third, 10th month, once you've settled down to a routine set of batch jobs that you're going to be running. Welcome to anybody who's joined. I'm Richard Nuckolls. We're talking about Data Lake Analytics Service, and we're getting one set up now to start looking at running jobs. It takes a couple minutes to get the service set up. Most of this is provisioning your initial cluster in the background and creating the metadata that's required to manage jobs in the Data Lake store that you choose. And now we've got our new service set up. In the beginning, the overview blade isn't that interesting. You can see we haven't run any jobs, we haven't spent any money, and we have no details about previous jobs. As you run jobs, this overview blade becomes more interesting, and it gives you an estimate of, are you going to meet or exceed your pre-purchased usage, and gives you an estimate of how much you're going to be billed for at the end of the month. So this becomes an important screen later, especially if you want to see what's going on currently with your Data Lake Analytics service. First thing we're going to look at here is the Data Explorer. This is built into Data Lake Analytics blade here. It allows you to do two things: look at the U-Sql catalog, which we'll look at later, and list your storage accounts which are connected and which provide the sources for data when you're running your U-Sql jobs. Right now, we chose during the setup EastUS2 Demo Dev Data Lake Storage Gen 1 service as our primary storage for this. But you can add more data sources if you have multiple Data Lake Storage Gen 1s, or if you have Data Lake Storage blobs. Data Lake Analytics will read from either one of those. Today we're going to be focused on reading from our Data Lake Storage Gen 1 because it makes it much easier. I do talk about reading files from blob storage and writing files to blob storage in the book. Let's jump right in and create a new job. I found when I first started learning about this service that this was the most intimidating screen that you could get when doing this. It has the highest climb to get to at least comfort with this service. It's a lot like Visual Studio in that way. You are presented with a blank canvas and you are able to put whatever you need to in here with very little feedback. It's also quite a lot like SQL Server Management Studio in that way. We have a couple of things that we get presented with here. We have a name for our job. We have the number of AUs, which is analytical units. This is the degree of parallelization that we can run our U-Sql job with, from 1, which is the basic and just has one node, up to 32 and more, depending on how many you want, how much data you have, how many steps in the analysis you need to do, and how much money you want to spend to shorten the processing time. We'll go over that a little bit later once we have a couple of jobs where it makes sense to analyze. So let me open up first script here. And show you what this looks like. This is a fairly simple script. It's got 3 main sections, which defines what you'll see in most every U-Sql job that you run. The first section is reading files into memory. The files use this, or the reading uses the extractors class, which has a method for the type of file that you're going to be reading from. It has a definition of the file or files that you want to read in. It defines the fields and the field types that your data will be stored in when it's imported. And it defines a variable called a row set variable, which references the data in memory. Something to note, the @ symbol defines a declaration of a row set variable. Actually, almost any variable in here, especially a row set. We've got 2 different commands that will create row sets. The extract command, which will read from files in the data lake store, and a select command, which will read from other row sets and create row sets. So now that we have our first section defined as reading from a CSV into a row set with a particular set of fields. By the way, these fields have to match what's in the file that you're reading. So for example, we have 5 fields here defined in this extract statement for this row set. There needs to be 5 fields in the CSV file that we're reading from. The Usql job will do a conversion from the data that it reads row by row into this row set, and it will do a best case job using the C# language definitions for converting the data in the field to this data type in this row set. So you don't always have to, you could define all of these as strings and your string data would import into strings, but you can use some of the power of C# to automatically convert strings in your data file into more interesting and powerful data types, which give you more options for subsequent processing. Now that we've got this first section defined, we can look at the second section, which is our analytics analysis processing. In this case, we're doing a fairly simple analysis, which is give us a count of this badge ID field usage per day. We're actually using a C# function here to flatten this event time, date time data type into a string, which is only the day, month, and year, or excuse me, it's month, day, year for the D. And any of you who are familiar with programming in C#, you can look up online the definitions for a lot of these shortcuts for the toString command. And we're grouping this by badge ID, door ID, and event time in this format, month, day, year, so that we're going to get all of our raw data into this players row set, and then we're going to do an aggregate with a count, which is a new field, by grouping all of these fields up, and we'll put that analysis output into the daily ag row set. This is a new row set separate from the players row set, which is holding our raw data. Two things to note here on this select statement. The first is if you can generate new rows or new fields in a row at any point in your select statement, but all of them must have any new fields or any reuse of a field must have the as attribute assigned to that new field with a text description or a text name for the new field. In the extract statement, we define the original field name and the field type. We continue to use those field names that we defined above here in the select statement when we're reading from that row set called players. But with both of these, an aggregate here of count, we have to give it a name with the as attribute. We're calling this one access count, and we're spitting out a formatted string from this event date time field. We're actually giving it a name with the as attribute of access date. You need to separate all of these fields with commas, and you need to conclude or end each statement with a semicolon. All of the statements in your U-Sql job will need to terminate with semicolons. All right, one thing I'll note as well, all caps words are reserved words in U-Sql. And that actually includes words that have more than one capital letter at the beginning. So capital AC, sesdate, would throw an error because this is being read as a reserved keyword and not having a match. So you can't use all caps words as names in U-Sql. Keep that in mind. The third part of this U-Sql script is the output. The format of all data handling U-Sql jobs works the same. Read data, do some processing on data, write data. There is no intermediate work with data in memory in a GUI, or work with data and write back to the original files, or read data, do some work with data, and then stop. All U-Sql jobs all U-Sql jobs which work with data have to have an output statement as well at the end to output the data. Otherwise, the compiler will actually throw an error and tell you that this job doesn't basically do anything rather than just spend money reading data into memory. So all of your data processing jobs will have an output command using the outputters class. Like the extractors class, you've got several types of built-in file types that you can read from: CSV, TSV, and plain text, which actually allows you to define all of your separation characters, your end rows, and various other settings on the file import and export. So with step 3, writing out to files, we have to use the output command and specify the row set that we're outputting. In this case, we have 2 row sets defined in this job, the players row set here at the start and the daily ag row set here. But you can specify, you can create multiple row sets throughout your job, and often that is the easiest way to process and understand and structure a Usql job so that you can read the job and know what it's going to be doing. And occasionally you can get benefits from multiple staging of processing, where processing in a single row set command either takes a long time or would force a single node to do all the processing, which then slows down the parallel processing of the overall job. In this case, we have the raw row set here that was used from the extractor, and we have a process row set which holds our aggregated data, and the daily ag row set is the one we want to write out. We'll have a using command like we did for the extractors, which defines the file type we're going to get plus some parameters. In this case, we're going to output a header, which will include the file names that are defined in the row set that we're writing out. One extra step that this output uses that the extractor did not use is a variable defining the file that we're going to work with. In this case, we have a string variable called out, which defines a path to a folder and a file name for our processing here. In the extractor statement, we said we'll look in the staging folder, demo folder, and read access_00.csv. And in our outputter, we're going to go to the curated/demo/v1 folder and write daily access count single.csv file. So now that we've defined these 3 sections, let's go ahead and submit this job to run. In this case, I've selected only a single AU because this job is not using a lot of data. I've uploaded a data file, which we'll take a look at here in a moment, called access_00.csv, which has 5 million rows, and it's about 300 megs. So we're going to be reading that data in here in a moment. So the process of submitting a Usql job gets your cluster ready to go. It submits the Usql to a .NET compiler, which converts the SQL language, C# language, and Usql into actual .NET code, which then runs on one or more nodes in the cluster. And the Data Lake Analytics service is managing spinning up the cluster, spinning up all of the nodes, running the compile process, distributing the code to all of the nodes, in this case just one, and each of the nodes handles reading of the data files and doing any intermediate processing and doing the subsequent and final processing and writing out the files in the end. As you can see, we have a update of how the job is processing here. We spent 26 seconds prepping, which was reviewing the Usql code for errors, doing a compile, checking for compile time errors, and then submitting that job to the cluster. If we have multiple jobs running and we don't have any available AUs in this Data Lake Analytics service, then we may actually have the job queued for a few moments, or multiple moments, or multiple hours. And then once there are enough available AUs to run the job, then it's submitted to one or more nodes in the cluster, and then it begins to run. This job ran for 51 seconds. Actual processing of data reads and writes, and now it's completed. We have 100% progress on here. We can see the script that we submitted here. We can take a look at the data that was read and written, inputs and outputs here. And because these are CSV files, various types of text files, we can actually get a preview of the data here in the window. You can see this file had a header row with these IDs, and here's the data in it. In our outputs, here is the file that we wrote out. You can see it also has a header row, since we defined that in the outputter. And you can see the format, text format of the data in the file here. You can see we've grouped these up and grouped them by door ID and access count. But you can see they're a bit random here because we didn't define any type of ordering for these. Last thing we can look at here is the AU analysis screen. This gives you can use this to determine how efficient your job ran, and is there improvements you could make if you were running this job a second or third or multiple times to balance how fast it will run against how much it will cost to run. In general, once you get to a certain level of data, running a job at 1 AU is always going to be the most efficient. It will run as long as required to get the entire job done, up to 6 hours per node, but it will not take advantage of any parallelization, as in read multiple files, write multiple files, or do multiple filters and calculations in memory on multiple nodes when it's running. It will only use a single node and run sequentially from start to end. We're going to look a little bit more at this when we run some more jobs. At this point, let's go back to our new job screen and run another job. As we saw before, for running a job, we need a job name, a number of AUs, and a script. Now that you've seen how we structure the Usql job with our input, our calculations, and our output, you can have some idea what we'll see for another job. So this job, quite similar to the previous job, although we've introduced another string variable here. As you can see, just like we did for the outputters, we can use a string variable to define the files that we want to read or write. In this case, the n variable is going to be used in the extractor to define this particular field, or this particular file to read in. And you can see this would run exactly as the previous job ran. But what if we've got more than one file that we want to read in? Well, in that case, U-Sql provides a wildcard notation for defining multiple files. It's best practice to use a string variable to define your ins and outs targets for your files. It also makes it a bit easier to actually build one of these wildcard statements if you need something more complex than just star.star. In this case, we've replaced the _00 single file name of access_00.csv in the previous script with curly braces and a star. The curly braces define your wildcard statement, and the asterisk or star is interpreted by the extractor class as being take any value that fits with the rest of the string, defining the path to the file. So if we take a look at our Data Explorer here, straight from the job, we can take a look in the staging folder, demo folder, and you can see there are actually 7 files here defined, access_00 through access_06. And with the access underscore curly braces star format here, we will read in access_00 through access_06 into our extractor statement and into our player's row set. What this means is all of the data in all of these files are going into a single declared row set, so they can all be addressed and read and processed in a single command, whether that's select aggregations with other types of SQL commands or written out to a single file. In this way, you could actually aggregate various files of the same type into larger files. Say one thing for data lake analytics efficiency and in general big data processing pipelines, larger files tend to read and write more efficiently than smaller files. So if you are planning your data collection processing and you're going to end up with thousands of 5 and 10 meg files in your data lake, you're likely going to be introducing inefficiencies in the pipeline processing later on, where having tens of 100 meg files or 1s and 2s of gig files actually improves the efficiency of processing in your batch analysis pipelines later on, whether that's data lake analytics or HD Insight or Databricks, any of your other types of processing. Most of these are based on HDFS and other types of Hadoop background services. So Hadoop is better at reading larger files and can break down larger files into parallel reads for faster reads and faster processing. That goes for Data Lake Store and Azure Storage as well. Both of these do break your files down in the background into smaller extents so that the services themselves can stream from disk in multiple pipes to get your data faster into whatever service is reading it in. This is especially important in Data Lake Analytics, where we can use immediately parallel processing for reading these files and writing the files out, so that if we have multiple nodes available, we can either read multiple files at once if they're small enough, or we can read from multiple simultaneous streams from the same file because of the way Data Lake Store and to a certain extent storage account blobs are split across multiple backend storage services. That's an aside. Generally, you want your file sizes for best efficiency to be between 250 megabytes and a gigabyte each. But Data Lake Analytics will read files larger than a gigabyte, I think larger than a terabyte. I think it's something like 6 terabytes for the max. Don't quote me on that. So we can, after having all that said, we can actually scale this up to read a few files at once. We can take advantage of some parallel processing in this. So I'm going to use 3 AUs to run this job, and we'll run all 7 of these files at once. Let's submit that job and see how it looks. While that job is running, I want to show you one of the calculations I've done over the years in prepping for this book and using Data Lake Analytics to back up some of the claims I've been making just now. I ran a series of tests with various sizes and counts of files at various numbers of AUs, analytical units, to see how efficient the jobs would run, how efficiently they would run, because efficiency means best use of your spend on the processing. If you've got 100% efficiency in your job, then you've wasted no money to get it done. You've also taken the maximum amount of time to get it done, but that is the trade-off that you can decide to make when doing or when using Data Lake Analytics for running your batch jobs. So in this case, I prepared 113 meg files and 1.1 gigabyte files in multiple counts of each, either 10 or 100, and then ran them at 1 AU, 2 AU, 4 AU, 8 AU, 16 and 32 AUs to see how efficient each job with each file size would be. You can see here the squares indicate the 10 113 megabyte files, which is basically a gigabyte of data for a Data Lake Analytics job. Actually very, very small for most big data processing jobs, you'll see. And even at 1 AU, it only got up to 70% efficient. So this was a bit slow or a bit wasteful for running, but it also didn't cost very much at 1 AU. As you can see, the efficiency drops quite a lot, from 2 to 4 to 8. Very wasteful when running 10 files at 100 meg each with multiple AUs. It's much more interesting to see what the processing differences are between that and once you've got to, let's say, 10 gig or 100 gig, or 10 gig or 30 gig worth of data, you start to get enough data to make your parallel processing nodes very efficient in both reading the data and processing the data. As you can see, with one AU at least 10 gigs of data, you are having very efficient jobs running. The efficiency drops more slowly, off from 2 to 4 AUs, and then it drops down quite a bit once you start running 8 and 16 because it's just not enough data and not enough files to justify using that many AUs or parallel nodes in your cluster for processing. So keep this in mind. Just because you may have a lot of files to run in, you may have spent or wasted money using more AUs and not got much in the way of speed reduction in processing those. So now this job has run. We can take a look at the job graph here. It shows us that we read 7 files in. It was approximately 4 gigs altogether from the extraction. 89,000 rows, sorry, not 5 million rows. And with our aggregate, we took it down to 29,700 rows, and we wrote out 723 kilobytes in the last step here to the daily access count vault. Here's our script again from before. Now you can see we've got 7 files rather than just 1 for our inputs, and once again 1 output here. So before we had the same set of data here. Now you can see the access count field has increased significantly from 170, 180 to 1200. So that's a pretty good indication that we're still on, or that we're reading our data in and we're doing the calculations properly. So here at the AU analysis, we want to look at this closely and see what we can learn from reviewing this screen. Because the AU analysis is helpful in retrospect, but it won't reduce your cost for what you had just run. It will allow you to reduce your costs if you run this job or a similar job again in the future by allowing you to choose a number of AUs to run the job at, which will maximize your, or will minimize the amount of time the job runs and also minimize the amount of cost for that time, while also minimizing the amount of wasted time for your AUs. Let's talk about the AUs, or analytical units, for a moment. The AUs are basically a node in a cluster that you define for use on a particular job at the start of the job. The AUs are defined, spun up, and run through the duration of the job, whether that job is a minute or an hour. And you are charged for each AU that you choose to put on the job for the entire duration, regardless of whether the node is actually being used. The charge is $2 per AU per hour, calculated at a minute rate. Actually, it's probably closer to a second, but at least a minute rate is an easy way to look at it. In the case of this job, we used 3 AUs. We had 0.08 AU hours altogether, so our charge was 17 cents. Our efficiency says it was 56% on this one. We had a bit of data here, but we didn't have enough to make full use of all of the AUs for the entire period. And if you are running anything over 1 AU, then you're unlikely to get anything close to 100% efficiency. But our AU analysis will allow us to review the running of the job and see if we've got a good return on the money we spent here, or if we have room for improving or shortening the amount of time it takes to run this job in the future. So we've got four different spaces here. We've got the actual use. We ran it at 3 AUs, and we got 56% efficiency on it. The Data Lake Analytics service gives you 2 recommendations for what they thought you could run this job at in terms of AUs, to either balance your spend with improving your or minimizing your time spent running, or maximizing or minimizing the amount of time spent running by maximizing the nodes that would be run effectively. This doesn't mean running every node available. This just means running the most useful number of nodes to get the shortest amount of time for processing. You can also set a custom number of nodes here and see what the graph looks like for that. In this case, if I choose 8 AUs, this line up here indicates that 8 AUs would never have been used in parallel. We only had 3 AUs used at once in parallel at any particular time. For a period of time, we had 1 AU in use only. So 1 node of the cluster was running some stuff during the aggregation, and then 2 nodes were running during another part of the aggregation and the writing out to the files. You can also take a look at this more closely. If we just select 2 AUs here, we can see the black line is our actual and the purple line here is our custom estimate. We can see that if we had chosen 2 AUs, we would have run at 2 AUs, 2 nodes, all the way to this point, run at 1 AU for a period of time, and then back to 2 AUs for a period before ending. You can see this was 83 seconds to run at 3 AUs. We're up to 109 seconds to run at 2 AUs. And then with the single AU, we're up to 191 seconds to run for all of this data. So as you can see, you can review your usage and the efficiency of the job for the AUs that you selected after the job is run. These are estimates. They aren't always accurate, but they are within 15%, I think, error rate of how close they'll get to the actual after the run version. But as you can see, this one would have cost 12 cents for 1 AU, 14 cents for 2 AUs, and it costs 17 cents for 3 AUs. So as you can see, the time changed quite a bit. It got shorter, going from 1 to 2 and going from 2 to 3, and the price also increased. So if you can trade money for time, or if you want to trade time for money, you can determine how fast you want the job to go to a certain extent. All right, take a break for a moment now. Thanks everybody who has been watching. Thanks for joining. This is Manning Publications Twitch stream. I'm Richard Nuckolls, the author of Azure Storage Streaming and Batch Analytics. currently in MEEP and out this fall from Manning. And I'm presenting on Azure Data Lake Analytics. I'm setting up the service to running your first jobs, to analyzing your jobs and getting the most bang for your buck when running these. All right, we're here for a little while longer. Let's take a look at some more stuff here. Now that we've seen what running a job looks like in the portal, we take a look at what running a job looks like in another way. So I've got a U-Sql project in Visual Studio 2019. This is a nice feature of Visual Studio starting, I think, in 2015 up to the current. You can add in the Azure Data Lake and Stream Analytics tools extension to Visual Studio, and it allows you to create both ASA job projects, Azure Stream Analytics projects, and Data Lake Analytics projects, which is the U-Sql project type. And here we go, U-Sql database project, or U-Sql project. Database project is for creating the U-Sql database in your Data Lake Analytics system. U-Sql project is for containing U-Sql jobs and U-Sql scripts for deploying to your Data Lake Analytics service. I am currently logged in with the same Microsoft account that I used to log into the Azure portal. And this gives me access to browse my Azure resources. In this case, I have a EastUS demo dev 2. This refreshed here. There we go. Now we have EastUS2 demo dev 2, the service that I set up at the top of the last hour. We only have the master database so far in there. But here in the Server Explorer, we can actually go and pull the data back from Data Lake Analytics service and view the jobs that we have run there. So we have new job, which was the job number 1 that we loaded up. We can see processing times that we ran. We can see the job graph for reading the files, reading the file in, doing our processing. We can see the files that we read in and wrote out. We can see if there were any errors running through. We can do the same type of AU analysis that we did with in the portal. And you can see if we had ran job number 1 with 3 AUs, we would never have used any of those. We could have used 2 AUs for a period, but then we were back to 1 AU and done. We also have diagnostics information that we can view just like we can in the portal for this job. See over here in the top right corner, load profile, which actually goes and gets the bulk of the data from the portal, from the service, Data Lake Analytics service, and loads it here into the Visual Studio so that we can read through it. And we've got our analysis and all of the data that we had there in the portal. You can actually play back through the process just to see how it goes through. This can give you some more details on how exactly things were running. It says we were using 2 nodes here, also three vertices, 2 vertices, 1 vertex. Each AU can have up to 4 vertexes each, but when you've got multiple vertexes, you can split them between various nodes. Each vertex will also handle the reading and writing of the data files. So we can do some management of the Data Lakes Analytics service from Visual Studio here. We can also write scripts directly in Visual Studio and then submit them both to our Data Lake Analytics service and run them locally. So I'm going to create a new script here. Here's our U-Sql script type. And one thing you will notice is we're still pointing at a folder path, a relative folder path here, but this is on my local machine. How can it get access to the data in Azure? Well, it doesn't. You actually need to set your data locally on your computer, and you do that somewhere here. There we go. So here in Data Lake Analytics, we have a local machine set up. And if you click on that, you can see over here in the properties of that, we have a data root, which defines the folder path on the local machine, which is equivalent to the data lake store that's defined in the Data Lake Analytics service. So you need to recreate your folder structure and files here in this data root for them to be read using this relative path here when submitting jobs on your local machine. So we have this script set up here. It's basically the same that we ran on our Data Lake Analytics instance in the cloud, but we've selected local machine for submitting this job to. Let's go ahead and submit that. I've also added in access_00 here in the staging demo folder on my local machine, so this file is available. See, because this is a project, Visual Studio is building it. It's built a little differently, but we're doing the same type of compile and build here that we would do as part of our processing in Data Lake Analytics when the U-Sql script is compiled and submitted to the nodes. In this case, since we're running it locally, we have at max a single node to run it on. And my machine is running a little slowly at the moment, building and running this. There we go. Completed the build. We have a command window that I can see that you cannot. That is monitoring the cluster that's running on my local machine with a single node. So we're running through the SV1 extract step at the moment. Continuing to run at 100% on my computer because this node, as they would in Azure, uses all the resources available to run at the maximum speed. And streaming while this is running does not appear to be a very good idea. While that's going, take a moment to welcome anyone who's here online watching the stream. Thanks for joining. This is the Manning Publications Twitch stream. I'm your guest author for today, Richard Nuckolls. I'm the author of Azure Storage Streaming and Batch Analytics on Manning Publications. And the book covers data lake analytics in great detail, and I'm talking about setting up a data lake analytics service from start to finish. And now we've finished. We have finished running that. Here is the compile view. Here is the script. And that's it we get for this. Well, because we are logged in to our Azure account, we've connected this account up and we have a service in Azure. We can actually also submit this script directly to our data lake analytics service in Azure. As you can see, we can choose the number of AUs up to 32 for this. And we can submit it directly from Visual Studio there into our cloud service. Here in the output, you can see we're monitoring how the processing for this job is going. And if we go back to the portal, we can see now in our job management blade, script 1 just submitted by me is now running along. Since this is a job in progress, we can actually click in and see real time how it's running, even though we didn't submit it through the portal here. In Visual Studio, now that we've got this job up and running, we can see the same details that we had for previously finished jobs here in Visual Studio for a running job. And it looks like we've gotten to 100%, and we're waiting for another refresh to show this job is complete. If we want, we can load profile, get our data back from the Data Lake Analytics service. And take a look at all of the settings and all of the tabs that detail the data for this job. One of the benefits of using Visual Studio to do your development work is you have access to Intellisense for U-Sql. See, string is not correct. String is correct. Also, if we happen to run a extra comma here, we'll get squiggly lines to show us that that's incorrect. And if we're running here, we can submit this script and see immediately that we've got errors. Reserved keyword from. It's reading from now as a name of a field. And give us another error here, so take that away. Submit that again for checking. And now the build runs. All right. While that's running in the background here, let's take a look at another feature of Usql and Data Lake Analytics. Showed the Data Explorer earlier, talked about how you can add more data sources for reading data, providing data, and having a target for your data outputs from your jobs. There's also a catalog view. The Usql catalog is a metadata container for groups of assets that look like groups of, for databases, which are groups of assets that look like items you might find in a database. These are tables, views, functions, stored procedures, and one unique item here is actually assemblies. These are precompiled DLLs, C# code, .NET code, typically, that you can store in your data lake, reference in your Usql scripts, and add extra functions and extra classes to functions in the processing that you do in your Usql jobs. By default, your Usql or your Data Lake Analytics service generates a master database in your target Data Lake store. So every Data Lake Analytics service will have a master database. The master database is available by default to all Usql scripts, but that doesn't mean you can't create more Usql databases. So let's see what that looks like. Just a moment, I'll get that script open up. So the U-Sql database is just a container for all the other assets that do things. And as such, you really only have two options: create and drop. You can create a database from scratch using the create database and then database name for the parameter. Or you can include an existence check when creating your database. You can also use the format of drop database and create database. Again, all lines, all statements need to end with a semicolon, and commands reserved words are in all caps. Let's go ahead and submit that job. This is a metadata job rather than a data processing job, and as such, it should only be run with 1 AU because it will only ever need 1 AU, and it doesn't take much time at all. It simply gets submitted to the store and the updates are made in metadata. So it runs very fast and it costs no money. So that's it. If we go back to our Data Explorer now, we can look in the catalog and see that we have a database called Stadium. Still has no tables or other stuff in it, but we can, this is where it starts to get interesting. Now that we have a database, we can start adding things to it. There are several different types of objects you can add to your U-Sql database. One of them is a view. One of them is a table. Tables are pre-compiled or pre-gathered and sorted data files that are stored in your data lake within the catalog and make it easier for you to retrieve data and make it faster to retrieve data that is used repeatedly in U-Sql jobs. Let's say you are generating large files, large daily files every day, and you wish to read those files each month. Maybe you wanted to get all the data every month, but last month's data wasn't that important. So each day you loaded all of this data up, and each month you queried for only a particular door. In this case, we've got an event time, a badge ID, and a door ID in this data. And let's say you wanted to see all of the data for a particular door activation for the entire month, and you ran this report every day. You could run this job and read all of these files as the month progresses, more and more data each day. Or you could run this table setup and pre-index and pre-order your data every day for the month, or once at the end of the month. Every day for the month is probably the best. And then you could read from this table, and this table will allow you to use predicate pushdown to filter the amount of data that you are reading for that query. And what do I mean by predicate pushdown? I mean, we have structured our query, or we've interpreted our query and structured our data such that we can read only the data that we need rather than entire files or entire sets of data. So we get to minimize the read time and therefore the overall batch processing time for getting the data that we want. So in this case, we've structured this table so that it's segmented out by door ID and ordered by event time. Let me give you some more background on that. So we're creating a table here. This table has a field definition and it has an index. The index orders and marks off where the data in the subsequent table storage fields is aligned. Each of the table files that back the storage of this table is split by a specific field value. In this case, we're going to use door ID. The ID that we're splitting this backing storage files on is closely tied to the queries that we're going to be using for and the predicate pushdowns that we want to optimize for. In this case, if we had all this data for the month in here and we wanted to run data over the whole month, but we only wanted the data for a particular door at a particular time, then we would optimize the storage of the backing data files for querying by door ID, so that if we only wanted to see door ID 1, we would then only read the door IDs, or we'd only read the backing data files that have the door ID. And Usql is smart enough to create backing files and do a round robin, or in this case, a hash distribution across the files, the backing files, so that we only have to read from the files that have this door ID in, rather than all of the files each time we run this report. One thing I want to draw your attention to is the use database statement here at the top. Because we have a U-Sql database called master, which is available to all scripts by default. By default, all scripts have use database master assigned to them in the background, tacitly. In this case, we will actually want to put this table into the Stadium database rather than the master database. One reason we'd want to do that is so that we can keep management of the database separate from master. In this case, if we start loading data into the access data table in the Stadium database, at some point we are storing extra data, and if we want to remove all of that data, we can drop this table, or if we have multiple tables, we could drop the entire database. You don't want to drop the entire master database from your data lake analytics service, and I don't think you actually can. So having tables and other types of objects included in a separate database rather than the master gives you more options for managing access and end of life for those assets. I know this is getting a little complicated and a little complex here. I'm trying to explain it quickly enough. I go into more detail in the book, Azure Storage, Streaming, and Data Analytics on Manning Publications. again, this creation of the table is a metadata operation, so it works pretty fast. If we go back to our Data Explorer, look in the stadium and the tables, we can see now we have a table called access data. So nothing in here currently. Query table will actually generate a U-Sql script for us if we want to run a query and get an output of that data. Using data tables and views is one time when you won't have all 3 or 4 of your sections in your U-Sql job. In this case, we get to skip the extract statement because we have already theoretically extracted data and input it into the data table for our use. So in this case, we get to go straight to the select, and then we can follow up with the output so we can see the data. So that's okay, but it probably would help if we have some data in this table to look at. Maybe we'll save that for another time. So I actually prepared another script to demonstrate how to use a view. A view is very similar to a table where you define the fields that you're going to get and you can read directly from this view, just like you read directly from a table previous script. But in this case, you're not preloading the data into the U-Sql catalog, into that U-Sql database. You are reading the files on demand, and you're actually defining the extractor. So the view actually allows you to move a commonly used extract statement from your U-Sql job out to a reusable bit of code, so that when you write your U-Sql job, you just have to you just have to call a select and generate a row set on the view rather than writing your extract statement again. As before, we're going to use the database for Stadium rather than the master database, since we'd like to keep these separate for management. We've got 2 commands here, the create view to create a view and the drop view to drop it. It's standard practice to drop the view first and then create it. You can include the if exists parameter to prevent any errors if the named view doesn't exist when you try to drop it. Otherwise, your compiler will throw an error whenever you try to drop this if it doesn't exist. So you can then create a view, and as starts the statement for extraction. And you see this is the same type of extract statement that you might use in a regular U-Sql job. In this case, we're using a wildcard as well to just read all of the access files in this staging demo folder. This is also a metadata operation. We are defining the view here rather than reading the data, so this operation happens pretty quick. And now that is done, we can look in our Data Explorer catalog, Stadium database, and see that we have a view. You can define the views as reading from tables, reading from extractors, or reading from other views. So now that we have this view here, we can click the query view and generate a new script. And when we have this new script, we can then use it immediately to read from that view. Let's grab a path here. So as before, we've got a fully qualified path here for our row set. In this case, we know actually, or the U-Sql compiler will know what database to reference to find this view. If you don't want to use the fully qualified name, you can specify the database to go to, and this view will be searched for just in this database and the master database. And you can see we're generating a view row set. We're going to write the row set out to this file path. And we submitted that job. Now, this job will actually run using the view that we defined earlier, and it will start reading all of the files because we're actually reading from the view. The view then pulls the extractor definition out and adds that to the compiled job, and then that is what's submitted to the nodes. So we've got reuse for not having to rewrite the extractor statement, and we didn't have to have the overhead of storage for preloading the data into a Usql table. But now we have to have the expense of actually running and reading the data into memory before we can use it. In this case, it's a trivial example since we're not doing any sorting, any filtering, or any aggregation. But once you start with gigabytes of data that you're reading into memory, you can see the benefits of either structuring it one way or another. So we're reading 7 files here in, and we're going to be writing out a single file with all of these rows once they have been read into memory. Now you can see that we're reading the files that we defined with the wildcard in the view, and they're being read in. So we're going to get probably 4 gigs altogether of read here. Thanks for anybody who's just joined. We're looking at Data Lake Analytics service in Azure. We've gone through setting up the service and running your first jobs. Now we're looking at setting up artifacts in the Usql catalog, which are reusable pieces of U-Sql jobs, either data storage or data access code that allows you to write U-Sql jobs faster with the reuse, or plan your querying and data retrieval so that multiple repeat retrievals of the same data are faster and more efficient. In this case, we've had a very simple script. We defined a view in the Stadium database. Then we created a new script that selected from the view, which then, in the definition of the view, read from 7 files, and then we just wrote all of those rows out to a single file here at daily access view. See, we had the 7 files here that were read in as defined in the view, and then single file that was written out here, daily access view. This is what you get with a very basic type of outputter file. This is a tab separated view with no headers defined, no alternate data markup or quote separation or any of that. All right. One last thing I want to cover before I go. We've got 2 places that you might want to adjust later in your use of Data Lake Analytics. When running the jobs earlier, you could see that we had a maximum of 32 AUs that we could apply to any particular job. And those maximums are defined here in the limits and policies under settings blade. We've got a couple of things we want to look at here which might be of interest. You have this setting for 30 days retention for metadata and details in your Data Lake Analytics jobs. After 30 days, Data Lake Analytics will remove the compiled assemblies and other artifacts of the job from your Data Lake store so that it reduces the ongoing storage costs for those. Every job that you run has artifacts associated with it outside of just the data files that you read in and data files that you write out. And these are stored in your Data Lake store in the system folder. And changing the job retention days allows you to either keep those details for those jobs longer at the cost of storage fees, or reduce the number of days that you keep those to reduce the storage fees cost. Maximum AUs and maximum AUs per job are 2 related sliders. By default, you get 32 AUs, which allows you to run some pretty big jobs or allows you to run multiple jobs at once. Up to 32 single AU jobs or 16 2 AU jobs or any combination thereof. If you want, you can increase this number even higher than 250 if you want to call Microsoft support to enable it. But one of the nice things about having the slider low in the beginning is it prevents you running too much cost over a day or a week or a month accidentally. The maximum AUs per job allows you to set the number of AUs that any job can use even if you have more AUs in your total Data Lake Analytics account that could be used. The maximum AUs prevents any one job from becoming too expensive for a set amount of data, or allowing any particular user to submit a job which only needs to run at 2 or 4 AUs from running 16 or 32 AUs and wasting a bunch of money on a particular job. So between setting the maximum AUs for the account and the maximum AUs for a job, you can control how your users submit jobs and how expensive and how inefficient they can run. You can also control the maximum number of jobs that can run at any one time. This particular blade is only accessible to admins. So this is one only the admins will want to manage for your Data Lake Analytics account, and leave your contributors and readers of the account just running the jobs and submitting new jobs. All right, that is it for today's streaming session. You can see that Data Lake Analytics is a powerful system which allows really quick and easy access to data and easy to use queries to extract analysis from big data sets. And it's not something you have to pay up front. It's something you can pay on demand and as you use it and as you get better at it. It even gives you the option for testing out these scripts on your local machine with Visual Studio.